Hello everybody, I hope you're doing really great, and I really hope the videos are helping. If you need anything else, more examples, just we're all learning this as we go, so let me know. But my intention with this video is to finish up your notes, the odd numbered items on the notes on the review, so you can be ready for test 3. So on number 31, your job is to write the equation of the line satisfying these given conditions, and it says to put it into y equals mx plus b. Okay, and then on 31, you are given slope and y-intercept. So slope, y-intercept. Well, this is slope intercept form. So as soon as you have slope and intercept, you have the equation of the line looking at you. Excuse me. I'm making this video a little bit early in the morning, and I have just a little bit of allergy, so I'm going to be clearing my throat a little bit, and I apologize ahead of time for that. So there is 31. Here comes 33. Now on 33, they switch it up a little bit. They give you the slope and a point. Now you have a couple of options. You can use, since we have the point and the slope, you can use what's called the point slope formula. And you'll find that, I believe, in section 4.5. And that just looks like this. Excuse me. So remember, this is x and this is y. So I'm going to plug in here and here and solve. Now you might like this or you might not. I have two ways to do a problem like this. Okay, so with replacing my variables with what we know, slope is 3. You can do that way, or, so you have this form, and I wanted to show you this because you do see it in Connect Math. I prefer just to do this, because what do we have? We have y equals mx plus b. We have a y. We have an m. We have an x. We need b. And there, so we still have y equals 3 is our slope, and then plus 0. And of course, the most concise way is just to write this. So if you have the point and you have the slope, you can use your point slope form. And now you'll see some little subscripts here. That just means the first y and this, I mean, those are, it's just a way of describing something that might look the same, but it's really different. So there is 33. And 35. On 35, man, they all we know is these 2 points. Passes through the point 4.3 and 6.7. So we're graphing lines here, and all we know about this particular line is 2 points on the line. So we started off knowing a lot about the line. We knew the slope and the intercept. We're ready to graph, really. Then they gave us a little less information, just the slope and a point. And so we used point slope or slope intercept to find the equation of the line. Now all we know is a couple of points on the line. Well, with a couple of points on the line, I can find the slope. And recall that slope is the distance between the y's over the distance between the x's, right? It's the change of the y's over the change of the x's. And you heard me earlier talking about a vertical change over horizontal change, right? So let's take care of that right now. And again, you'll see in your formula y2 minus y1, x2 minus x1. That's just to delineate, like if this is 0.1 and this is 0.2, because you have to keep it consistent. All right, let's go. So let's go 7 minus 3, 6 minus 4. 7 minus 3 is 4, 6 minus 4 is 2, 4 divided by 2 is 2. And now this is cool. So now we're going to use this information and do a similar problem that we had before. So now I have that the slope is 2. I'm going to choose one of the points. And once again, you can either go point slope, we'll do that. Let's do y minus y is the slope times x minus x. Right, there's using point slope, or you can use slope intercept. So here's y equals m times x plus b. And so here's my slope, here's my y-intercept. So it is the same. There's 35. Here comes 37. On 37, they're changing concepts a little bit, still in the realm of functions, but the functions look a little different. So on 37, we have this equation. Really all that means, just as a little bit of an aside, you know when we had a second ago y equals 2x minus 5, that's the same as f of x equals 2x minus 5. It's really the same thing. So don't let all of this, confuse your mind at all. It's just another way of writing the same thing. And this particular one, this tells me, since I have an exponent here, I'm going to have some sort of a curve. If I were to graph that, I'd have some sort of a curve. Here, my highest exponent is 1, so that will always yield a line on your graph. It says to evaluate p at negative 2. So A, we have p at negative 2. So that means that everywhere where we have x, we can plug in a negative 2. So let's make a little x bucket here, another x bucket, and I'm going to plug in the value that they gave me for x and solve. All right, and so what that essentially says that when x is 2 in this equation, when x is 2 in this function, y equals 6. It's the same as having this point somewhere on this graph. And then what B is asking you to do is to determine the degree. Well, the degree of a polynomial is just the highest exponent. That's it. No big a deal. And what's the highest exponent in this function? It's 2. So here the degree equals 2. That's all you need for that. Now we go to 39, and that will conclude our test review for 3. All right, so on 39, we're given a set of points. Let's go down here and make sure I have plenty of room. This is a set. and we are asked to identify the domain. Alrighty. The domain of any sort of a relation is just the set of all inputs, which is the same as the set of all x's. That's all. And so if we're listing the set that represents the domain, it's simply 1, 2, 3, 4. Even though it says 1, 2, 4, 3, it's best to put them in numerical order. Then we have to identify the range. The range are your outputs or your y's. And for this one, the y's are 2, 3, 1, 7. So let's go 1, 2, 3, 7. So there's your domain and there's your range. Now, is it a function or not? So is it a function? It's a function if every output has a unique input. So that means that each of your x's has to be different. So if I'm listing my x's here, none of them repeat. So we say yes. Now let me give you an example of when you would say no. So let's say that this was a 1, 2, and then 1, 3. The fact that these inputs, that these outputs share an input, that would cause it to not be a function. If this was 4, 1, and 4, 7, same thing. The fact, if you get one input that repeats, then it is not considered to be a function. Okay, so this gives you all of the notes that you need for test 3. Please refer to your daily assignment sheet. I will be sending an email test, so there's no, my computer's fine. The test will come through the email. We'll do the same testing protocol as before. We will complete the test on that day during class time on that day. So please refer to your daily assignment sheet and reach out to me if you need help. Take care, people.